In today's lecture, we will discuss the topic on circles. In this lecture, we will include these four topics: angles and circles, chords of circles, and tangents of circles, and the last, mensuration of circles, that is area and perimeter part of the circles. So before going into the lecture, let's understand certain basic terms related with the circle. So first one is a chord. What is a chord? A line joining two points is known as the chord. So what is a secant? A chord in extended form. If you extend the chord in this form, this is called as secant. What is tangent? A line touching the circle, just touching the circle, is known as tangent. What is sector? This part of the circle is known as the sector. This part is known as segment. This part is known as arc. So if your circle is this way, this is your chord. This is your major arc, this part, and this is your minor arc. So please understand these basic terms. Now let's go into the lecture. The chapter on circles we discuss in four parts: angle, chords and tangents, and common tangents. I included a lot of figures. These figures are related with the angles, these all figures are related with chords, these are related with chords and tangents, and these are common tangents. Why I included these figures? आपके most of the questions in SSC or other competitive exams either directly based on these figures या फिर वो आपके डायरेक्टली कहीं ना कहीं रिलेट करेंगे इन फिगर से. यू प्लीज इफ यू हैव क्लियर अंडरस्टैंडिंग ऑफ दिस फिगर्स यू कैन इजीली सोल्व और इजीली मैनेज ऑल द क्वेश्चंस बेस्ड ऑन द सर्कल्स. So please pause the video and clearly observe these figures for some time, and we will discuss these figures in detail in next few slides. So let's go to the next slide. That is, there are certain properties, we will discuss certain properties on angles. So let's see first. Two angles by same chord. If suppose this is a chord and two angles by it are always same on same side, on this side of arc, are always equal. If this is x, this will also be x. Next is your central angle is twice of this. You suppose this is the center of the circle and this angle will be always twice of these angles, so 2x. Next is your two angles by same chord on opposite sides. If one angle is x on this side and there is one angle opposite on the opposite sides of the circle, then sum of this angle and this angle, these are complementary. Suppose this is theta, so sum of x plus theta is always 180. So theta will be your 180 minus x. So this angle on opposite side of the chord is always 180 minus x. You can memorize or summarize all these properties with the help of this diagram. This equal to this will be double central angle, and this opposite angle will always be 180 minus x. Property number 4 is your angle subtended by a diameter based on this figure. You suppose this is a chord, but if you make it a diameter, then angle subtended by diameter is always of 90 degree. Next is your alternate angle of chord are equal. What is an alternate angle? Suppose this is a tangent and this is a chord AB. So this angle and this angle is known as alternate angles, and these are always equal. Next is your sum of opposite angles of cyclic quadrilateral. What is a cyclic quadrilateral? If all the 4 points of a quadrilateral are on the circle, then it is called a cyclic quadrilateral. What is its property? Sum of opposite angles. Sum of opposite angle 1 and 3 is always 180. So 1 plus 3 always 180. Similarly, opposite angles 2 and 4. Sum of 2 and 4 is always 180. This is important property. Please remember it. So now let's discuss certain questions based on these properties. I already discussed these diagrams in the last slide. So let's see the questions. O is the circumcenter of triangle ABC. Suppose this is a triangle ABC and O is the circumcenter. This is your circumcenter O. So BAC is given 85, this is given 85, BCA is 75, BCA, this angle is your 75. Find OAC, you have to find OAC, this much angle OAC you have to find out, you have to calculate. Suppose this is x. So now let's see what happens if this is 85. By this property, central angle will be double. So double of 85 will be 170. Similarly, by chord AB, if this angle is 75, then this angle, central angle will be double. Double of 75, that is 150. So this is 150, this is 170. So what is this remaining angle? Suppose this is theta. So this will be, because this total circle is of 360. So 150 plus theta plus 170 is equal to 360. So theta will be 360 minus 150 minus 170, that is your come will be 40. So this angle theta will be your 40. So now please observe this triangle. Triangle AOC, this triangle. In this triangle, this is radius, this is also radius. So these are two equal sides. So angle opposite two equal sides are also equal. So if this is x, then this will also be x. So in this triangle, x plus 40, x plus 40 is always 180, because sum of angle of a triangle is always 180. So 2x plus 40 or 2x is equal to this much, and this will be 2x 40x will be your 70 will be your answer. So this is your answer is 70. Now let's discuss next question. PQRS is a cyclic quadrilateral and PQ is a diameter. Suppose this is your center. So PQ is your diameter and PQRS, suppose this is your cyclic quadrilateral. PSR is 130. This is given 130 and RPQ you have to find out. RPQ means this angle you have to find out, this much angle. So let's see, because this is a diameter, PQ is a diameter. So let's apply this property. This angle will be, angle subtended by diameter will be 90. If this is 90, and let's apply also the property of cyclic quadrilateral. Sum of opposite angles always 180. So sum of S plus Q, this much, is 180. So S is your 130 plus S is your 130 plus Q is equal to 1. This Q will be 180 minus 130, that is 50. So this is your 50. This is your 90. Suppose this you have to find, this is x. So x plus 90 plus 50 is always 180, because these are sum of angle of a triangle. So x will be your 180 or x will be your 40, your answer. This is your answer. Next question is a simple one and you can try yourself. Now let's go to the next slide. In this slide we discuss the properties of chords. So first property is simple one, perpendicular from the center. Perpendicular from the center, bisect the chord. Bisect the chord. This is a chord, suppose this is 10, so it bisect the chord 5 and 5 and 5. So next property, line joining centers of two intersecting circles. Line joining centers. If this is a line joining the centers of two circles, is perpendicular bisector. This line is perpendicular bisector of what? Common chord. This is your common chord. So it is perpendicular and bisector. Bisect this chord in two halves, x and x, this chord. So this line is perpendicular bisector. Third is equal chords are equidistant. Suppose this is a circle. If this is a chord and its length is x and this is another chord, x length, same length, equal chords are equidistant from center. So this distance and this distance will be equal, and vice versa, and opposite also true. So equidistant chords are equal in length. Next is your equal chords subtend equal angles. Suppose this is a circle and this is a chord and this is other chord, equal in length, x and x. So angle subtended by this chord and angle subtended by this chord is always equal. This angle and this angle are equal. Next, your fifth property, angle bisector of equal chords. You suppose this is AB is a chord, x length, AC is other chord of x length. So angle bisector of these chords is always passes through the center, always passes through center O. So these are properties 3, 4 and 5 are actually properties on or equal chords, equal chords, equal chords. So you please memorize, please pause the video and clearly observe these properties. Next we discuss properties on tangents. That is, first property is perpendicular to a tangent. If this is a tangent and a perpendicular on this always passes through the center, and reverse is also true, and a line passing through the center is always perpendicular to the tangent. So let's go to next property. Two tangents from any point are equal. If you draw two tangents from this point in this way, these are equal in length, and this angle, this much angle and this much angle, sum of these angles is always 180. These are supplementary angles actually. Suppose this is angle is theta 1, this is theta 2, sum of these angles will always 180. So these are supplementary angles. So this is also an important property. Please memorize all these properties and draw these diagrams at home again and again. So now let's go to the next slide. We discuss certain questions based on this question on chords. Now first you observe these diagrams. What is the common between these diagrams? Let's see. What is commonality? All these diagrams have right angled triangles. So this is your right angle triangle, this point, this is also a right angle triangle, this is also right angle triangle, this is also right angle triangle, this is also a right angle triangle at this point, this is again a right angle triangle, this is again right angle triangle, this is also. So right angle triangle. In a right angle triangle you can easily apply Pythagoras theorem. So this is one. Second is, many of these triangles are similar. So concept of similarity you can apply here. So if you remember, you know these two concepts clearly, you can easily find all the questions, you can easily solve all these questions. So as you know, you have to apply Pythagoras theorem. You can please remember these basic Pythagorean triplets. What is the use of this? If you remember this, you need not to apply again that Pythagoras theorem. Suppose this is, you know that two sides are 9 and 40. Suppose this is 9 and this is 40. So this always be 41 by direct remembering this. No need to calculation of squaring plus 9 square under the root and calculating. So these are basics. I only put basic triplets here. Questions are directly coming from this. Let's see. Directly they are asked question in the competitive exam. Now let's see the first question. In the first question, radii of two circles are 9 and 15. Chord of greater circle is tangent to smaller. If this is greater circle, this is a chord to greater circle AB, and this is tangent to the smaller circle touching at this point. So this radii you have given 9 and this radius you have given 15. So how you calculate, this is a right angle triangle. So how you calculate this length? By this triplet, two sides are 9 and 15. So next is your side is, this will be 12. So what is the length of this total? 2 into 12, double of 12, that is 24, your answer. Now see next question. Equal circles of radius 4 cm intersect. Equal circle 4 cm radius, that one passes through center of other. If this is a circle 4 cm and this is another circle of equal radius 4 cm, this circle passes through the center of this circle and this circle passes through the center of this circle. So this is your 4. This is actually also your radius. Please observe this diagram. Now what you have to find? You have to find common chord. This is your common chord. So this total is 4, then this will be 2 and this will be 2. And this radius is again your 4. This is also the radius. Na? You observe this diagram. This is a right angle triangle. So this length is, let me change the color. This is your length is 2, this is your 4. So by Pythagorean theorem this will be 4 square minus 2 square is equal to, this you calculate will come out root 12. So this distance is root 12. So total distance will be 2 into root 12. That is your answer. This will be 2 into root 12. This question, next question is a simple one and based on this diagram. So in this question, two circles of same radius 5 cm. Suppose this is one circle, other circle with radius 5 and 5. So intersect at A and B. AB is 8. Suppose this is A and B intersecting at this point and this point. So this chord is 8. So this will be 4, this will be 4, this is 5, this is 4, so this will be 3. By this triplet you have no 5 and 4, so this is 3. So if this is 3, your total this will be 3 plus 3, 6. Your answer. Next is a typical question and please observe it. Chord PQ of 6 cm. This is your chord AB, suppose. 6 cm means this will be 3 and this will be 3. Of a circle with radius 5 cm. This length is given 5 cm. Tangents at P and Q meet at T. Sorry, this you take this chord as P and Q, not A and B. P and Q. Tangent and P and Q meet. If this is tangent and this is tangent, meet at point T. Find TP. You have to find length of this. Actually, this question is based on the similarity concept. You know, we discussed in the triangles, special triangles, that this is a right angle triangle. If you draw a hypotenuse, then this triangle, and this complete triangle, all triangles are similar. So this is based on the similarity. In this, if this is O, this is suppose A. So if you can find out, one second, let me erase this. You can easily check if suppose this is O, this is A. So triangle, this is 90. By property of these circles, this is also 90. So let's see, in the triangle OPT is similar to triangle OAP, and corresponding part, this is O is O and P is with A. So OP divided by OA is equal to PT divided by AP is equal to OT divided by OP, and you please put the values. You have to find out PT, so you have to find out this length. OP is your 5, OA is your, this much OA is your 4. Actually if this is 5, this is 3, so by triplet this will be your 4, so OA is your 4. So PT is divided by AP, this is your AP is your 3, so PT will be by cross multiplication 15 by 4, that is your answer. If you divide, this will be your answer. Now next we discuss the questions on secants. These questions are based on these figures and directly come in the examination from these competitive exams, from these diagrams. So these are based on these formulas. So in such, if there are two chords AB and CD and intersect at point P, then what happens? PA into PB, PA multiplied with PB is equal to PC multiplied with PD, this formula. And this formula also work for this kind of, if this point is P, so PA multiplied with PB is equal to PC multiplied with PD. Next is also PA in this diagram, PA multiplied with PB is equal to PT multiplied with PT, PT into PT, that is you can also write it P2 square. So remember these formulas, you can easily solve this question. Let's see. Now let's discuss next question, that is tangent PT. If this is a tangent PT and chord AB meet at point P, this is based on this diagram. So, and this is I wrongly put, this is actually AP is equal to 2PT. So please correct it. AP is equal to 2PT. So PT suppose your X, this is your X, then AP will be twice of PT. So AP, this much your 2X. So this is your 2X, AB is given 18, this is given 18. So apply this formula. How you apply? PA 2X into PB, PB is this much 2X plus 18 total length is equal to PT square, square of this PT, X square. So this will come out to 4X square plus 36X is equal to X square, and this come this side, 3X square is equal to 36X, X cancel out, 3X will be 12 is your answer. That is your answer. Now let's discuss this question, that is first one. Two mutually perpendicular chords AB and CD, suppose this is AB chord and this is C chord, mutually perpendicular, intersect at P, this is point P and this point is P. AP is equal to 4, this is 4, PB is equal to your 6, this is 6, CP is equal to your 2. So what will find radius you have to find out this circle. So let's see, by this theorem, this 4 into, so by this diagram and this formula you observe 4 into 6, this into this 6 is equal to 2 into, suppose this PD is equal to X. So we'll take it PD as well. So PD will be 12, so this distance is 12. So now let's observe this diagram. If you put a line here, then this distance will be, this total will be 14, 12 plus 2, this total CD is equal to 14. So this is bisected at this point, so this distance will be 7. So if this is 7, this much is your 2, so this remaining part will be 7 minus 2 is equal to 5. So this much distance is your 5, this much distance, let me change the color, this much distance, this is your 5. So now observe AB is total length is 10, 6 plus 4, 10. So this half, it is half at this point, so this will be again 5, 10 by 2. So this is 5 and this is 5 and this is a right angle triangle. So what is the radius? This is 5 and this is 5. By Pythagorean, 5 square plus 5 square under the root, that is 5 root 2. That is your answer. Radius will be 5 root 2. Next question is a simple one and you can try yourself. Now let's go to the next slide. In the next slide we discuss the questions on the common tangents. So this form is called common tangent, direct common tangents, and these are actually transverse common tangents. So you can directly use the formula to calculate. This is your d, distance between the center, this distance d, minus r1 radius of this circle, r2 radius of this circle. You always use plus sign for transverse, plus sign for this type of tangent, and always use minus sign for direct tangent. So let's solve a question. Two circles with radius 9 and 4. So radius is given 9 and 4, touch each other. Suppose these are two circles touching each other. So the radius 9, this radius 4. So distance is between 9 radius, this is 9 and this is 4. 9 plus 4, distance 9, 13. So distance between center is 13. So 13 square minus r1 is 9. So for this type of, you take minus sign. So that 9 minus 4 square. So under the root, this will be 169 minus 9 minus 4, 5 square. So this will be 169 minus 25, so 144, that is your 12, your answer. So now let's go to the next slide. In this slide we discuss the mensuration part of circles, areas of circle. That is always pi r square, simple formula. Perimeter is equal to 2 pi r. You just take this 2 in front, 2 pi r and pi r square. What is sector formula? This colored part is your sector actually. This whole part is your sector. So this is your actually theta. Suppose this is theta. So what is the area of the sector? Just multiply. You please observe here. If this is the area of the circle, this is perimeter of the circle. So what is the area of the sector with theta? Nothing but multiplied theta by 360 to this value pi r square. Similarly theta by 360 to this. This is your perimeter of the, this is length of the arc, this much. This is length of the arc from this point to, and this is your area of the sector. Next we see the area of the segment. What is a segment? First you check. This part is the segment. So now you know the area of this complete sector, already discussed this part area, and subtract this triangle area from that. So remaining part will be this. So area of segment, this part will be area of sector minus area of this triangle, and this can given by this formula. And similarly perimeter, you can also take length of the arc, this is the length of arc, plus length of the segment. You can easily calculate the perimeter also. Now first question, find the ratio of areas of inner circle and circumcircle of a square. Suppose this is a square and this is your inner circle, and this is your outer circle. So what is the ratio between the areas of this circle and this circle? If they want just only ratios, so if the ratios of areas will equal to, if you know the ratios of radii square. अगर आपको ratio of radii का पता है, you can find the ratios of areas easily, ratios of radii. So just calculate the ratios of radii. So this is length is your, suppose this length of this square is suppose a. So length of the side of square is a. So this will be your a by 2. So this length is the actually radius of the inner circle. So this is actually a by 2. Radius of inner circle is a by 2. And this diagonal is actually represent the diameter of the outer circle. Please observe this diagram. You draw with your hand and observe it. This is diagonal is actually diameter of the external circle. So radius of external circle is this much. This much is equal to root 2a. Root 2a is actually diagonal of the square, and root 2a by 2 is your this much radius. So radius of bigger circle is root 2 by 2a, and smaller circle is actually a by 2. So ratio of these two is actually 1 by 2, and it reverses in this form. So root 2 by 1, and the square of this root 2 by 1 is equal to nothing but 2 by 1. That is your answer. Now let's see the next question. That is 3 coins of each radius 1 centimeter touching exactly each other. So 3 coins are there. This one, this one, this one. Of radius 1. This much is 1. So this total will be 2. So this will also be 2, this also will be 2. So this is equilateral triangle, and angle of equilateral triangle as well 60, 60 and 60, all three angles 60, 60, 60. So now this is one segment like this. If this is angle of 60, so how you calculate area of this? Theta by 360 means 60 by 360 into pi r square. Pi r square, radius is your 1. So 1 into 1. So this will be pi by 6. So answer will be your pi by, this will be your, this segment is pi by 6. This is also pi by 6. This is also pi by 6. This one is also. So 3 into pi by 6. So this will be 3. This will be your pi by 2. So segment areas of all these segments is pi by 2. And the area of this total triangle, whole triangle, is equal to 3 by 4 a square, means a is the side of the triangle, 2 into 2. This is the area of equilateral triangle. So this will cancel out. So area of triangle is root 3. So this remaining part, let me change the color. This part, area of this will be this total triangle root 3 and minus these segments, 3 segment area, that is pi by 2. So your this will be the remaining area, this part, area of this part. Next question is a simple one, and find the area of segment formed by angle of 90 degree. Direct formula, you can use this one. And next question, the sector of 120, this angle is 120, cut from a circle and area of this. This is also based on the direct formula. You can try yourself these two questions. Now let's go to the final slide. This is summary of the lecture. We discussed all these diagrams in details, and the chords we detail this all questions based on the Pythagoras theorem, right angle triangle, similarity. These all we discussed properly. And you please keep into your mind these figures. Please clearly observe and keep into your mind. If you know these figures exactly, you can directly and quickly solve the questions on the circles. So this is the end of your lecture. In the next lecture we will discuss the mensuration part, that is area and perimeters, volumes of cones, cylinders, spheres, hemispheres and so on. So thank you.